Assalamu alaikum, welcome back to my YouTube channel. Today my topic is about oscillation motions. The repeating back and forth motion about certain equilibrium mean position is termed as oscillation or oscillation motion. The same motion repeats over and over. A, a particle goes back and forth over the same path and exactly the same way. Following are few terminology associated with oscillation motion, cycle and vibration. One complete round trip of the vibrating body about means position is called vibration cycle. To complete one vibration or cycle, the particles must be at the same point and hitting and the same direction as it was at the start. Time period. The time required to complete one cycle is called time period T. The time period is measured in second. Frequency. The number of cycles that the particle completes per unit time is called frequency F. The unit of frequency are cycle per seconds or hertz at Z. Relation between time period T and frequency F. Time period and frequency are reciprocal of each other. Displacement. The distance of oscillating body from the mean positions at any instant of time is called its displacement. Displacement is measured in meters m. Amplitude. The maximum displacement of the body from its mean position in a cycle is called amplitude. Amplitude being a length, it's measured in meters m. Simple harmonic motions. Vibration or oscillation is repeated back and forth motion are along the same path. Vibration occur at the point of stable equilibrium. An equilibrium point is a point at which the net force acting on the body is zero. An equilibrium point is called stable point when its small displacement from its the net force push the body back to the equilibrium point. Such a force is called a restoring force. Since it tends to restore equilibrium, consider a ball and ball example. Under stable equilibrium condition is shown as an figure. When ball is displaced from its equilibrium position, it will start moving under restoring force toward equilibrium position opposite to the displacement as after reaching equilibrium position the object will continue under inertia and will reach the other extreme position and thus it will continue to oscillation back and forth. Simple harmonic motion is a special kind of vibration or oscillation motion which occur whenever the restoring force is proportional to the displacement from equilibrium mathematically. When the net sign that the restoring force F is directed toward the equilibrium position opposite to the displacement x, we can also define simple harmonic motion in terms of acceleration is the type of motion in which the acceleration is a is directly proportional to the displacement x and is directed toward the mean position. Equilibrium 10.2 and equilibrium 10.3 repeated the condition for simple harmonic motion. Motion of mass attached to springs. Consider a block of mass m attached to one end of elastic spring which can move freely on a frictionless horizontal surface is shown in figures. When the block is displaced, the elastic restoring force pulls the block toward equilibrium position. For an ideal spring that obey Hooke's law, the elastic restoring force F is directly proportional to the displacement x from equilibrium positions. Since F and x always have opposite direction, therefore we can a negative sign and equilibrium each spring is different and so is the force required to deform it. Thus, the motion of mass attached to spring is simple harmonic motion restoring force, reduced acceleration, and the body given by Newton's second law of motion. Comparing equilibrium 1 and equilibrium 2, we get ma is equal to minus xx, or a is equal to x by m by x. A spring constant Kn mass m does not change during oscillation of mass attached to spring, therefore they are regarded as constants. Of the restoring force obey Hooke's law, the oscillatory motion of mass attached to spring simple harmonic.